All right. Hello, everybody, and welcome to MME 4310 Polymer Engineering. I'm your instructor, Dave Robertson, and I've put together this kind of introductory video so we can talk about a little bit what we're going to do in this course. Before we move on, I wanted to kind of bring your attention to this video. And this video deals with what's kind of been my passion for the past 4 years or so, which is shape memory polymers. This is a relatively novel polymer blend that we developed to be compatible with fused deposition modeling type 3D printers, also called fused filament fabrication. And we can make parts that you can have a temporary shape and you heat it up and it goes back to its permanent shape. And for whatever reason, shape memory polymers have kind of become a passion of mine. We'll definitely talk about shape memory polymers and the many mechanisms in this course. It's a little bit different than shape memory metals. If you've had that, shape memory metals are primarily driven by a phase change, but there's different mechanisms in polymers that can come into play. So we'll definitely get into that. But again, this is an introductory video for the class, so I wanted to make sure that I welcome you to the class. It's an online version, if you haven't realized that yet. So welcome. The recommended text is Introduction to Polymers by Robert J. Young and Peter Lovell. I hesitate to say required text because I have a few reading assignments that I assign out of it. It actually is a good reference book. I'm pretty sure it's the accepted text in a lot of polymer science and polymer engineering curriculums. It is put out by CRC Press. And if you're not familiar with CRC Press, they're makers of the CRC Handbook for Chemistry and Physics. CRC is the chemical and rubber company, and they kind of have a rich history in polymer processing, actually. So, recommended text, Introduction to Polymers, gotta love the purple. If you're a Minnesota Vikings fan or Los Angeles Lakers fan, you have to have this book. I'm just saying. Kind of a course outline, so straight out of the syllabus. We're going to talk about Introduction to Polymers and Organic Chemistry Basics. I'm going to kind of merge these two topics and not have them be kind of digital. We're kind of going to go back and forth from Introduction to Polymers and Organic Chemistry Basics because you can't really do one without the other. Then we're going to get into the basics, nomenclature, basic polymer structure. I don't think we get that much polymer structure and polymer stuff in our curriculum because we're a metallurgy-based curriculum for the most part. Then we'll talk about polymerization, polymer blending, polymer rheology, thermoplastic composites, a subject that I like quite a bit. Polymer processing, polymer additive manufacturing processes, which I've decided to kind of break out from polymer processing. Mechanical properties, which maybe I want to have a little earlier. We'll see. It's a tentative course outline. Failure analysis, shape memory polymers, which is one of my passions. And I feel I may want to put this final topic a little earlier, and I'll try to find a better place for it to fit. And this final topic here is the environmental impact of polymers. And it's becoming more and more prevalent in the public eye, the kind of mal-effect polymers have had on our environment. And if you went to the last Order of the Engineer, which was the December 2019 Order of the Engineer, the keynote speaker, I mean, this is pretty much what her talk was about, was how polymers have negatively impacted our environment. In a lot of ways, they've negatively impacted humankind. There's also a lot of benefits. I mean, there are several people that owe their lives to polymers in one way or another. And so there's kind of good and bad, but we need to really, as a society, take a look at the environmental impact of polymers. One thing that we kind of want to think about is what do we think about when we hear the word polymer? And a lot of people, if you just ask them on the street, what do you think about when you hear the word polymer, either look at you and go, oh, or say plastic. If you Google polymer, and I Googled it, and it took about 0.72 seconds to come back with a response, I got a definition here, which is a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together For example, many synthetic organic materials use as plastics and resins. Now, I don't necessarily like this definition. What's nice is it has the Greek word palu, which means many. So poly for us is many, and mers, palumus, well, mers or something else. So we'll get to what a mer is. Anyway, so it has the kind of Greek going in the German mid 19th century word for polymer. Notice it says mid 19th century. I think that may be slightly incorrect, and I'll tell you why here in a little bit. I like this definition better. I am greatly remiss because I don't remember where I got this definition from, so I'm a little embarrassed putting it up here. But polymers are materials composed of large macromolecules, which actually macromolecules was the word people assigned to polymers when the science first started getting started. So polymers are a material composed of large macromolecules constructed of smaller repeat units, which are MERS. These MERS are held together by covalent bonds. For whatever reason, I like this definition a lot better. The MERS are held together by covalent bonds, and so the individual polymer chains themselves are strong, but the chains are typically bound together by weaker bonds, which are called dispersive forces or collectively van der Waals bonds. And we'll talk about that in a bit more detail as the semester progresses. A lot of times when people think of polymers or plastics, they do think of the environment. As I've said before, it's coming into the public eye more and more. There is a cycling team that was sponsored by Team Sky. Ironically, now this same team is sponsored by a chemical company, so I think they've kind of abandoned their Pass on Plastic campaign. But there's so many disposable things. So polymers and plastics in general end up being this cheap, useful material and inexpensive. So they're used for a lot of disposable things. And so it ends up getting in our water system, causes a big mess. Plastic bags, I go riding my bicycle out in the desert a lot of times, and I see a lot of plastic bags on the mesquite and creosote bushes. And plastic bags that make up a large component of trash. Several stores now are kind of ending the use of plastic bags or making you pay a fee if you use a disposable plastic bag. And so maybe now in the time of COVID, it's frowned upon to bring in your own bag, but kind of overall for the past few years, the use of disposable plastic bags has kind of been frowned upon. Water bottles, which are polyethylene terephthalate for the most part, disposable water bottles are also pretty common. There's some problems with those because it's felt that the chemicals from these plastic bottles can leach into your body. And then the oceans, there's these great garbage patches, and we'll talk about this a bit more in this class. But a lot of times when people think of polymers nowadays, they think of trash and waste and kind of negative environmental impact. History of polymer, I tried to put it on this older looking brown background, but polymers have been used by humankind, by our society, for quite a long time, and polymers occur naturally. So I shudder a little bit when people just say plastics. Proteins, wool, silk, hides, glues, those are all polymers, and they're natural polymers, and they've been used by society for a long time, been used by our humankind for a long time. Cellulose is a pretty common natural polymer. There's a lot of research going on in many fields using cellulose nanocrystals as a reinforcement, and we've done a little bit of that in my lab. Pitch, plant resins, pine tar, natural rubber, they're all polymers, and they're not synthetic, and they're not necessarily what we think of in terms of plastic. Natural rubber, big thing. A lot of advances in polymer chemistry occurred in the World War II timeframe because they were the United States in particular was looking at a substitute for natural rubber to make tires. And so silly putty is one example of that. And one thing I want to point out is a lot of polymers that we use on a daily basis, whether it's a polystyrene, ABS, they're not actually that modern. They've been used for quite a while. And so kind of wanted to point that out. A lot of polymers we use on a daily basis were developed a reasonably long time ago. And but there are some cutting edge polymers that are coming out. So we'll talk about that also in this class. Kind of wanted to point this out, how many metric tons of different polymers are produced, and this is just the US. Okay, so this isn't the world. This is just the United States making this. And so polyethylene, especially if you combine the different types of polyethylene, and this is all just the polymer structure that decides this: low density, linear, low density, and high density. Polyethylene is pretty common. If you go get a milk jug, it's probably high density polyethylene. A shampoo bottle, probably high density polyethylene. Garbage bags, high density polyethylene. Bag that you get from Target or Walmart, high density polyethylene. Very common, very thought of as very disposable. It's also very stable, so it's hard to break down, which contributes to the environmental impact. Although there's a lot of literature coming out where people are saying that they've broken a lot of these polymers down using UV light and the like, I don't know. Let's kind of see how this plays out. PVC is another very common one, and vinyl, if someone says this is vinyl, it's actually PVC that's been plasticized. And a lot of times when people think of PVC, they think of this rigid pipe. If you add a component called a plasticizer, you can make it less rigid and you can increase the applications. Very common application, again, is synthetic leather or pleather, used for clothing and car interiors. So that's another one. The one thing I'm a little surprised is so low is polyester. Because like my shirt's made out of polyester, and those water bottles are polyester. So I don't know, maybe this is telling me something, that high density polyethylene is pretty ubiquitous, even though polyester is ubiquitous. But if you look at the great number, so thousands of metric tons, so a lot of plastics, a lot of polymers being produced by our country. This table didn't come from the recommended text. It came from this book I've referenced here. So Joel Fried, Polymer Science and Technology. Many polymer texts out there for you to take a look at if you're so interested. We're going to start talking a little bit about polymer structure, and then we'll kind of cut it off, and then we'll make a segue into basic organic chemistry. But when we as metallurgists think about the structure of materials, we generally think of crystalline structures. And some polymers do have crystalline structures, but they definitely don't look like this. And we get this beat into us as students. So iron, BCC, titanium, HCP, aluminum, copper, FCC, crystal structure. These are crystal structures. This is generally how we think material is structured. Polymers are structured a very different way. The first thing you want to kind of take home when you talk about polymer structure is that all polymers have a backbone. And that right away differs them from anything metallic, okay? However, before we delve further into polymer structure, we need to familiarize ourselves a lot more with our, oh man, I've made a mistake. I got organic food on the mind. We really need to think of organic chemistry, which is carbon-based and not, food-based, my organic milk or whatever. So organic chemistry based on the carbon atom, and we will stop this introduction now and pick up our next lecture with an introduction to organic chemistry. So I thank you very much for your time. Looking forward to a good semester. Read the syllabus. We're going to pick up with organic chemistry basics in our second lecture. Thank you very much for your time.
Oh my. It's the end of the lecture. If you have any questions, you can email me at drobertson@utep.edu.